Hello guys, welcome to this session. My name is Wahid. Today I'm going to talk about denial of service in wireless LAN environment. How to think like a hacker or like an attacker uh, in order to bring down a wireless network in the simplest form possible. This is just for illustration to my students. For this demonstration, I'm using two mobile phones. In this case, my iPhone and a Nokia mobile phone. I'm using a Raspberry Pi machine with Kali Linux on top of that, and I'm also using network software suite called AirCrack that can be accessible on the security secforsecuritytools.org, sectools.org website. Kali Linux is a distribution of Linux built for the purpose of digital forensics and penetration testing. It is accessible on the Kali.org. Kali is based on Linux and a specific distribution, as I said, for penetration testing and digital forensics. The image that you download needs to be installed on SD memory card. How to do that and other details about that factor out for now. Let's start with wireless and see what wireless LAN means. So, a wireless LAN or WLAN is a type of wireless network that is commonly used in homes, in offices, and campus environments. So, you are very much familiar with your home router that provides internet accessibility for you. Uh, Wireless LANs, they make mobility possible within the home and business environments. So mobile users can wirelessly access the uh, wireless router, and through that they can get connected to the cloud behind the router. So wireless infrastructures are also good because they adapt to rapidly changing needs of users and changing needs of businesses and also the technologies. So when you compare it with wired infrastructure, you don't see this adaptability in a wired environment. We have different types of wireless networks. It starts with private area networks, local area networks, metropolitan area networks, and wide area networks. Our focus today is wireless LAN or local area networks, but also we have IEEE wireless PAN standard to be used for device pairing, and it can support of up to 100-meter distance in open space. This technology is very famous. You all know about it. Bluetooth technology is an instance of WPAN or wireless private area networks. We can also have wireless communication in the form of cellular broadband communication. And the internationally recognized standard for this GSM, Global System of Mobile. Wireless communication can come in the form of satellite communication or satellite broadband, of course, whereby we use directional satellite dish aligned with satellite in geostationary orbit, meaning that it remains stationary in relation to a fixed point on the surface of the Earth, and this orbit is uh, achieved at an altitude of almost 35,000 kilometers above the Earth. For satellite broadband, between that dish and the surface, you need clear line of sight. And fourthly, and finally, our focus today, it can come in the form of wireless local area network or WLAN or wireless LAN or WPAN or WMAN or WWAN, whichever you choose. Uh, our focus LAN for a medium-sized networks up to 300 feet. As with other aspects of communication, there is always standards behind the scene. We have IEEE as the Institute of Electrical and Electronics Engineering, or engineers, IEEE institute that provides the standardization for us, and in this case 802.11 is the name of the standard associated with wireless LANs or WLANs. And this is important because the organization IEEE specifies how radio frequency can be modulated in order to carry information. So for this, IEEE defines 2.4 gigahertz frequency and also 5 gigahertz frequency to be used for 802.11 or Wi-Fi or wireless LAN environments. When I'm talking about modulation, I'm not talking hopefully in another language. What I'm talking about is how the characteristics of one wave can modify or can be modified or can have impact on characteristics of another wave in a form that it can carry data zeros and ones for us. So this is modulation. So modification of the characteristics of the waves, and how radio frequency is modulated to carry information is specified by standardization organizations like IEEE. This is not only the case with WLAN, also with WMAN. IEEE is behind the scene for standards and their specifications. Towards the bottom of this slide, what you can see is a spectrum, and that spectrum is very important. I want you all to understand what we mean by electromagnetic radiation. Uh, Similar to other forms of energy, electromagnetic radiation, I'm sure you're all aware of, is a form of energy around us. It's all around us and takes different forms. It takes many forms. From left hand side of this spectrum, we can see radio waves. It can come in the form of microwaves. It can come in the form of X-rays, and towards the right hand side, it can come in the form of gamma rays. The reason I say you're all familiar with is because you're all familiar with sunlight. And sunlight is also a form of electromagnetic energy. But if you think of visible light, then we are talking about only a small portion of the electromagnetic spectrum. The spectrum itself is quite wide, as you can see, starting from left to right as the frequency goes up, and the spectrum therefore contains a broad range of electromagnetic wavelengths. Radio frequency or radio frequency waves, the focus of our discussion here for Wi-Fi or IEEE 802.11 technology, they are generated when an alternating current goes through a conductive material. We know that waves are characterized by their frequency and the length. So simply, alternating currents can carry radio signals, and therefore radio waves or radio frequency or RF, in fact, they are electromagnetic waves that can carry information for us or data for us with the speed of light in free space and that fast. RF, in technical terms, refers to rate of oscillation of electromagnetic radio waves, and in particular when we are bounded within the range of 3 kilohertz to 300 gigahertz frequencies, as well as the alternating currents that carry the radio signals. So that is also referred to as RF or radio frequency. This frequency band, in fact, or subdivisions of this range, can be used for communications and broadcasting and transmission of frames and packets. Now, back to our Discussion here about WLAN or Wi-Fi technology 802.11. All wireless devices, they operate in the range of electromagnetic spectrum, and in particular for wireless LAN networks, they operate in 2.4 and 5 gigahertz frequency bands. 2.4 in technical terms is UHF and 5 gigahertz is SHF. But that's beyond the scope of our discussion here. The next slide, I'm going to go through four different components of wireless communication. For wireless communication to take place, we have four components required. At very beginning, the first thing that we need is a wireless network interface cards or NICs. So to communicate wirelessly, all these machines, laptops, tablets, smartphones, or even the latest automobiles, they all include what we know as integrated wireless network interface cards or NICs that incorporate a radio transmitter and a radio receiver. This word transmitter and receiver together, they form another word called transceivers. So NICs or network interface cards, they incorporate radio transceivers. If a device, however, does not have an integrated wireless network interface card, then through a USB connection, we can have a wireless adapter and we can use that one. The second component of a wireless network is a wireless home router, the one that you can see at your home, or even it is called wireless router if it's not at home, if it's in business environment. So, but at home, what we have is a home user that typically interconnects wireless devices using a wireless router. Wireless router itself has three components, but you don't see them, but they actually are there. There is an access point there is a switch there, and there is a router there. And when we are technically discussing these terms, then there is a small difference between these concepts. We have access points when we are talking about wireless. So to provide wireless access to devices, we need access point subcomponent of home routers or wireless routers. At the same time, if you see back of the wireless router that you have at home, you see some ports available for wired communication. So that wireless router is also a switch, meaning that it gives you the ability to interconnect wired devices as well as wireless devices. So those wired devices are connected to the switch subcomponent of a wireless router. The third subcomponent of wireless router, as the name suggests, is a router that is there to route the traffic for us, to provide a default gateway to other networks, and that other networks, it can be the internet. So the router subcomponent of wireless router is there to provide internet connectivity for us. The third component is very important because that's the focus of our discussion today. With demonstration that I want to show you later. We have wireless access point or AP. When we have AP, then wireless devices, they need three stages to get connected to that AP and through that AP to the rest of the network, be it your private network, your corporate network, or even the internet. The first stage is that wireless clients, they use a wireless network interface card in order to discover nearby APs. Secondly, those wireless clients, they attempt to authenticate with that AP and later to associate with that AP. Thirdly, after being authenticated, the association, if it is successful, is established, and wireless users, they have access to the network resources. What you can see towards the bottom of this slide is a topology whereby we have what we know as an autonomous access point, and then a few wireless devices connected to that access point, and through that access point to the rest of the network. Access points can be categorized into two categories. We have autonomous access points, and also we have controller-based access points. The example that you see here, autonomous access points, they are standalone devices. They are configured through a command line, CLI, or through GUI, graphical user interface, either command line interface or graphical based user interface. Whichever you go with, they are autonomous in the sense that they act independently of the other components of the network, and in the sense that these APs are managed manually by the administrator. They are not managed automatically. So that's why we call them standalone or autonomous access points or APs. With more advanced scenarios, we've got controller-based access points or APs, whereby we can have a lightweight access points or LAPs, LAPs, and using lightweight access points protocol or LWAPP, we are able to communicate with wireless LAN controller or WLC. So there is a controller there, and that controller through a specific protocol communicates with what we know as lightweight access points or LAPs. Each LAP is automatically configured after that and managed through the communication with WLC. So WLC is the boss. It sits there. It controls everything. It has full control over the rest of the network. And then LAPs or lightweight access points, for any sort of configuration, they are in touch with their boss, that is WLCs. Fourth component of wireless networks, wireless antennas. Three types of external antennas in particular. We've got the omnidirectional antennas, we've got directional antennas, and thirdly, we've got MIMOs or multiple input, multiple output antennas. With omnidirectional antennas, they're able to provide 360-degree coverage, and therefore it makes them perfect for office users and also for houses, because the coverage fits the houses and office areas. We've got directional antennas, secondly, and directional antennas, they focus the radio signal in a specific direction. And this is also another category for antennas, external antennas that we have. And the third category is, in fact, a combination of multiple antennas. Up to 8 antennas together are used in order to increase the bandwidth, and they are called multiple input, multiple output, or MIMO antennas. These four are the main components of a wireless network. You also need to know briefly about the structure for the frames that are sent wirelessly. The 802.11 frame format is very much similar to what we know about Ethernet frame format, and the only exception is that the wireless 802.11 frame format contains more fields. You also need to know in advance that wireless communication with LANs or WLANs, they are happening half duplex. That simply means that you cannot send and receive at the same time. You either send or you receive, and that simply means that client cannot hear while it is sending, so making it impossible to detect a collision. Therefore, we need another technology called CSMA-CA. So wireless LANs or WLANs, they use carrier sense multiple access with collision avoidance, carrier sense CS, multiple access MA, and collision avoidance or CA, CSMA-CA technology, in order to determine how and when to send data to avoid any collision. But I'm not going to go through that in details. Instead, in next slide, I want to see in more details how a device is authenticated to an access point and where the vulnerabilities are. To be able to think like an attacker, you first need to understand how a technology is working, how it operates. In this case, how a wireless device gets associated with an access point. And after you come to know how things work or operate, then you can start thinking about vulnerabilities. And then you can start exploiting those vulnerabilities to cause damage in a lawful manner. Of course, we are here to learn to that system and then think about how to secure that system and how to stop attackers from exploiting those vulnerabilities. So in this case, we've got devices that go on the three stages to get associated with an access point. So wireless client and access point association. For a wireless device to communicate over network, they must first associate with an access point or a home router, a wireless router that you have at home. And for this, those wireless devices, they need to complete three stages. First, to discover a wireless access point. Secondly, to authenticate with that access point. And thirdly, to associate with that access point. For successful association to happen and to achieve this, a wireless client and that access point, they must agree on certain parameters. These specific parameters include SSID, password, network mode, security mode, and channel settings. These five are very important for a client and AP or access point to agree on, and after that, the successful association can be achieved. With SSID, what I mean is the name of the network. So the client needs to know the name of the network they wish to connect to. Then password is important, and both parties they need to agree on password. This is required for the client to authenticate to the access point. Then we have network mode, and as we have different variations of 802.11 running, the 802.11 standard that is in use is important for both parties to be aware of and to agree on. Fourthly, we have security mode and the security parameter settings. They must match on both parties. WEP web or WPA or WPA2, whichever the security parameter setting is, both parties they need to agree on. Fifthly, here very important, we have channel settings. I already talked about the frequency band for which 802.11 is operating, 2.4 or 5 gigahertz. That band is later subdivided into multiple channels, each allocated 22 megahertz bandwidth with 2.4 gigahertz band, and separated from the next channel by the margin of 5 megahertz. Whichever setting you go with, the channels on both sides they must match. So that's why with 5 gigahertz we have also 24 channels with 802.11 AM and AC variations, and then each channel is separated from the next channel by the margin of 20 megahertz. Later, we need to make sure that overlapping channels do not occur. So non-overlapping channels is what we are after, and therefore we may use certain channels and we may not use other channels. In fact, before I move on, it is worth mentioning that to plan a wireless LAN or WLAN deployment, the number of users supported by that wireless LAN depends on certain criteria. Those criteria include the geographical layout of the facility for which you want to plan a wireless LAN deployment, the number of bodies, the number of devices within that facility that can fit that space, the data rates that you are after, and of course the use of non-overlapping channels if you are using multiple access points and transmit power settings. So non-overlapping channels are important in that sense as well when you plan a wireless LAN deployment, uh, because it requires multiple access points to use non-overlapping channels uh, to avoid interference. And then when we plan a wireless LAN deployment, we also think of the location of the access point, where to locate it, and the approximate circular coverage area of that access point in relation with other access points within that deployment. That needs to be taken care of as well. Just before I move on to threats and security vulnerabilities associated with wireless LAN, what you can see towards the bottom of this slide is the scenario for the attack demonstration that I want to go through today. Uh, what it first tells you is the three stages required for a wireless device to associate with an access point. But in my scenario, I'm going to have two mobile phones, one Nokia phone, one iPhone. And the iPhone on the right hand side is going to act as the access point for me. And the Nokia phone on the left hand side is going to act as the wireless client. Then I want that wireless client to get wireless access to access point, i.e., my iPhone, through hotspot technology. Uh, by discovering that access point, by authenticating to that access point, and by associating to that wireless communication channel. After that happened, I want to bring down that communication conduit or that communication channel. The way that I want to use to cause this denial of service attack is by using what we know as the authentication frame. So IEEE 802.11 has some management frames and some control frames that are there for very valid and legitimate users. However, I want to misuse one of those frames or one of those control management frames that is already there by design in order to cause denial of service. This doesn't happen with the latest solutions for wireless, of course, but this can show the importance of this attack and the need to thwart this sort of attack. So, idea that I'm going to rely on is that this protocol does not require any encryption for control or management messages or control management frames by design and in definition, and that's why it is vulnerable. And if an attacker wants to exploit this vulnerability, we want to show that this is possible. So we need to think of a solution. So to sum up, on the right hand side, I've got my iPhone acting as the access point to provide wireless communication. And then on the left hand side, I've got my Nokia phone acting as a wireless client that tries to discover that access point, authenticate to that access point, associate the wireless channel to that access point, and then start communication with access point. Later, I'm going to use my third device, that is Raspberry Pi device that I have, to launch a DoS attack against that communication channel, wireless communication channel, and to bring that wireless network down and to cause denial of service at the end of the day there. Just before moving on to the attack, let's see what threats are wireless LAN or WLAN threats that are possible. Four categories here. Before everything, remember, wireless LAN is open to anyone within the range of the access point with appropriate credentials in hand to associate to it. And that's why it opens the door as well for attackers to try to exploit the built-in vulnerabilities there. Attacks can be generated by outsiders or intruders, but also with disgruntled employees, unhappy employees. They can cause the attack, they can generate the attack, they can start the attack as well. Or even unintentionally by some employees, they can cause attacks as well. So, uh, no matter which, wireless networks are specifically susceptible to several threats, including interception of data. Wireless communication is there in the air. You can intercept it, start messing around with wireless communication and the intercepted data. This is by wireless intruders. They can also cause other forms of attacks, including denial of service. So, intruders and then denial of service. Denial of service attacks can be caused as the result of improperly configured devices. It can be caused by a malicious user intentionally interfering with the wireless communication. And this is the case with the demonstration in the next slide that I'm going to show you. And also, DoS can be caused accidentally, accidental interference that can cause DoS as well. And fourth category of threats, wireless threats, include rouge access points. That is also when we have an access point or a wireless router that has been connected to a corporate network without explicit authorization and against the corporate policy and can start acting as a rouge access point that is not valid but is impersonated as a valid access point. To minimize risk of DOS attacks due to improperly configured devices or due to malicious attacks and attackers, we have a technique called device hardening. In fact, we harden all devices. We keep passwords secure. We make sure that we create backups every now and then, and we also ensure that any sort of changes, updates, upgrades, any configuration changes are incorporated off hours, not during the working hours. With Rouge access points, the very famous instance of this attack is called man in the middle attack because once the Rouge AP is connected, the device can be used by an attacker to capture addresses, to capture data packets from users, to gain access to other network resources, to launch a man in the middle attack, whereby the hacker is positioned between two legitimate entities in order to intercept the communication between them, to read, to modify that data that passes between two parties. So, a very famous instance of man in the middle attack is called Evil Twin AP, that is configured with the same SSID as the legitimate access point. What happens is that in order to defeat a man in the middle attack, you need to identify what is legitimate. So identifying legitimate devices on that wireless LAN is very important. Users must be authenticated, and then after legitimate devices are known and are authenticated and legitimate users are known, then that network can be monitored for any abnormalities, for any abnormal devices to be added or to be removed, or for any abnormal traffic activity. In short, we define what is normal and then we monitor and we look for any signs of abnormalities. Also remember, attacker can sit in a coffee shop and tries to use a personal network hotspot. In effect, he can change his machine to act as a root hotspot and can fool the user into that trap. So users, they don't know that, and then they just want free Wi-Fi, so they get connected to the Wi-Fi access point that is in fact the attacker. It's a root access point. So to prevent installation of root access points in businesses, what happens is that they configure what we know as wireless controllers. So with the more advanced architecture, if you remember, with uh, non-autonomous access point, we had controller-based access points, WLCs. With those advanced scenarios, root access point policies are there, and then we use a special software for monitoring the normal and abnormal activities. So monitoring software to actively monitor the radio spectrum for any sign of unauthorized access points. This is the way that we stop. But that's beyond the scope of the discussion here. For now, remember 802.11. Uh, in the design, it uses what we know as beacon frame. Is one of the management frames in IEEE 802.11 based wireless LAN. It contains all the information about the network, and they're transmitted periodically. So beacon frames are transmitted periodically. They serve to announce the presence of that wireless LAN to the rest of the network of wireless clients. And in order to synchronize the members of that wireless channel or that service set, beacon frames are there to serve this purpose. Two, beacon frames are transmitted by access points in what we know as infrastructure basic service set or BSS. The existence of beacon frame is now considered a security risk because it can provide much of valuable information to the attackers. So to address the threats of keeping wireless intruders out and protecting data, because protection of data is the most important goal of any cybersecurity system. Two LD security features can be used. We can have SSID cloaking and we can have MAC address filtering. With SSID cloaking, access points and some wireless routers, what happens is that they allow the SSID beacon frame to be disabled so that attackers cannot discover valuable information freely and easily. So wireless clients in that case, they must be manually added. Therefore, they must be manually configured with the SSID of the access point to connect to the network. The second technique we use for increasing security of wireless LANs or WLAN is MAC address filtering. That simply means that administrators, they can manually permit or manually deny clients based on their physical MAC address or based on their hardware addresses. So in addition to beacon frame as one type of control or management frames defined on the IEEE 802 standard, we've got another frame called the authentication frame. What is the usage of the authentication frame? Well, when I say usage, I'm looking for legitimate use of the authentication frame in Wi-Fi or IEEE 802.11 standard. The authentication frame, as one of the Wi-Fi's management or control frames, is there to force the device to re-authenticate. So the good news is that along with that frame, inside that frame, we have a 2-byte field that tells us the reason code for which the frame needs to be sent. The authentication frame needs to be sent to provide some hints for the receiver. But no matter what the reason is, upon the receipt of the deauthentication frame, the device needs to re-authenticate. So we misuse this feature, we take advantage of this behavior, and by using this behavior, we try to cause denial of service. But in legitimate use cases, we have non-trivial wireless deployments whereby multiple access points, they have the same SSID. So imagine that one of the access points within that network, they need to service. So for this, they need to get disconnected from the rest of the network rather than just simply turning it off and letting the clients time out, which is a very bad practice at the end of the day. We send a deauthentication frame with valid and legitimate reasons. And then inside the reason code under that deauthentication frame, we put reason code number 8. So we say this is disassociated because sending station is leaving, and sending station is that access point that we need to service. Because he has left the DSS, the stations they get disconnected and then re-authenticated with the rest of the access points of that network with the same SSID. Another reason code for legitimate use of the authentication frame is reason code number 5. So disassociated because access point is unable to handle all currently associated stations. Another reason code is for disagreements that can happen between the client and the access point, or any errors that happens during authentication or association of the wireless client to the access point. Just before I move on, remember that we can have a wireless mesh network and then we can conduct the same attack. We can uh, do the same attack by bringing down one of the components of that wireless mesh network. So, wireless mesh network, for those who are not familiar with, well, in a small office or home office Soho environments, we have one wireless router, and that is more than enough to provide wireless access to all clients. But you can extend that, and if you extend that, then you have a wireless mesh network because you can extend the range beyond approximately 45 meters indoors or 90 meters outdoors, and effectively create a wireless mesh network. To create that mesh, we just add more access points with the same settings. Uh, the only exception is that within those settings, we use different channels, and of course, that is to prevent any interference. So we extend a wireless LAN in a small office or home office uh, environment to create a mesh. And this application is very easy these days because manufacturers have made creating wireless mesh network with WMN very simple through the use of smartphone applications. They can extend wireless LAN, the range and the coverage easily. But that's beyond the scope of our discussion today. Just remember, if it's the wireless mesh network, then you add access point, and again, causing denial of service against any of those access points, bringing down the whole wireless mesh network because it's not covered by the required access points anymore. Now, misusing the authentication frame of 802.11, I'm going to conduct a DoS attack to bring down the wireless communication. Once again, I'm using Raspberry Pi. The Raspberry Pi that I bought can be seen in the figure here. And then I install Kali Linux on that Raspberry Pi, and then I use network software suite called AirCrackNG. This suite consists of a detector, a packet sniffer, a cracker for WEP, WPA, WPA2 pre-shared keys. It can act as cracker as well, and also an analysis tool for 802.11 wireless standard. This is very important because using three tools within this software suite, Airmon, Aerodom, and Airplay, using these three tools, I can sniff 802.11 A, B, and G variants traffic, and also I can inject packets. Using the first tool called Airmon NG, Mon for monitor, I place different cards, different wireless cards into monitor mode. so that they can sniff traffic. With AeroDump, after that card was placed into monitor mode, as I said, AeroDump acts as packet sniffer. It places air traffic into pickup files and shows information about networks. That helps with reconnaissance attack. I get access to the information that I need to use for conducting the actual attack later with Aeroplay. Aeroplay is a packet or frame injector. So I gather the information that I need and I put that into another frame for the attack to happen, and that frame is going to be the authentication frame to be able to bring down the wireless channel, wireless communication. The authentication attack that I'm going to show in a sec, in fact, targets the communication between the access point and the wireless device. It happens because we have the authentication frame, as I said, for legitimate users there. So it is sent from a router, wireless router, or an access point to a device in order to force that device to disconnect and to re-authenticate with the access point. One of the other use cases of, or legitimate use cases of the authentication frame is described as a sanctioned technique in order to inform a rouge station that they have been disconnected from the network. Just wanted to mention that one as well. You may see that in the literature. So we use this feature of 802.11 protocol to be able to conduct the attack. Better to say we misuse this feature of this protocol. We send that frame and then that resets the communication as the client to leave. With a spoofed address of the victim, we are able to uh, hit exactly the victim and ask him to leave the communication channel or wireless communication, effectively causing denial of service. This happens because the authentication frame is not encrypted by design, and for this reason, the only thing that we all need is the MAC address of the victim and the channel that that victim is operating underneath. So this is also in clear text and it is provided to us. So remember that this attack does not happen with the recent variations of 802.11w because with WPA2 and WPA3 technologies, we have what we call protected management frames or PMF feature of WPA2 or 3, and that stops sending these sort of control management frames in clear text, and therefore it stops them being forged. But for now, the authentication attack is doable with scenario that we have here: one Nokia phone as a wireless client, and then one iPhone acting as the access point, and then we target the communication between those two phones when the iPhone is acting as a hotspot provider. Aircrack in G Suite, as I said, can mount a Wi-Fi deauthentication attack, and that is uh, running over the Kali Linux distribution over the Raspberry Pi. So on the top left hand side, you can see that my Nokia phone is trying to find a Wi-Fi connection to get connected to. And on the top right hand side, you can see that my iPhone is a hotspot provider and it allows other clients to be joined and to share Wi-Fi. They require password 1234567 8. In the middle, you can see that I enter this password on my Nokia phone or wireless client so that they can discover, authenticate, and associate with the access point or iPhone, and then they can share the wireless communication with the hotspot. What happens is that on my Nokia phone, as soon as it gets authenticated and associated with the access phone, what happens is that I'm also streaming a video. Let's say I'm a very big fan of Pink Panther, so I start streaming that video, and later when I cause the DoS attack, I want to bring down the wireless channel, i.e., I want to bring down that online video streaming of Pink Panther. So towards the bottom left hand side, you see the first step of the attack is that to bring up the Kali Linux and to install the ACrack suite on it. For that, I open up Linux terminal and I put sudo apt install ACrack Linux sudo command. For those who are not familiar, it provides root privileges to normal users, so you become super user. And we have the option to upgrade individual packages or all packages if I go with sudo apt upgrade. So in this case, with particular package name, I go with sudo apt install acrack. The second step is exactly towards the middle of that image, whereby I issued iwconfig to list or to show what wireless cards are there and what they are called. As you can see with my Raspberry Pi, I've got wireless LAN 0, WLAN 0 as the only wireless card there. Ethernet 0 and loopback, they are not wireless, so that's why they are not listed in details there. What happens next is that towards the bottom right hand side, I issue a third command here now. I run airman ng start WLAN 0. This is where I put my wireless LAN 0 as my network card into uh, monitoring mode. So you put your card into monitor mode so that it can monitor all traffic on the network. When the wireless card is in monitor mode, what happens is that you can see every other access point or every other router around you. Just before you put everything that you can hear and eavesdrop from the air into a pickup file and display the content of that pickup file. Just before that, if at this stage I issue iwconfig again, now I can see in the bottom right hand side figure towards the end of the figure that I also have another wireless card, virtual, let's say, wireless card, because this is the same as previous WLAN 0, but this one is WLAN 0 MON, MON. That changes your network card name because that network card is now in monitor mode, so it changes to WLAN 0 MON. And the next stage, exactly this WLAN MON 0 is going to be used to form aerodump, or in other words, to form a pickup file and to display its content to the user. So we need to know exactly all the access points and the wireless routers that are connected and can be heard in wireless. So aerodump ng WLAN Xeno monitor is there, and it tells you every single router that it can hear, and it can show the result for it. Very important columns there. PWR for power, that shows you the signal strength, how close it is to you. It's very important. The closer it is, the larger the value for signal strength. And of particular interest is two pieces of information here: BSSID or MAC address of the wireless router or access point, and its corresponding channel. For this demonstration, my iPhone is called the Wahid's iPhone. So the MAC address associated with Wahid's iPhone in addition to the channel that corresponds to that PSSID or that MAC address, they need to be noted down and we need them later. Remember that wireless router or access point, they broadcast Wi-Fi signal to channels ranging from 1 to 11 here. So uh, different channels are associated here with different wireless routers or different BSSIDs. So be careful not to confuse them. And also, for those who are not familiar with MAC address, media access control address, the hardware address, and that address specifies the routers or wireless routers network card or wireless network card. Um, it has two parts, but that's beyond the scope of this discussion. I don't go through it in details. Now, in the next stage, I'm using the same command arrow dump, but this time I want to say, I want to be very specific. I want to say I would like to see all the wireless clients of that access point or that wireless router. For that, I issue this command arrow-mg WLAN 0 PSSID, and then I put the MAC address of the access point there, Wahid's iPhone in this case, and the corresponding channel number with hyphen channel, and I put channel. In simple words, I would like to see all the clients that are connected to Wahid's iPhone. I want to see their addresses, their MAC addresses, and then having the MAC address of the victim, I want to bring down the association between that victim and the access point. So we need to know exactly what the specific devices we want to boot off from the network. So we can see already the access point. And this network, with this example, I only have one wireless client device, that is the Nokia phone. So you write down the MAC address for the victim, that is the Nokia phone, and then in the later stage, from the top left hand side figure, what you see is that I create the authentication frame using AirPlay ng the auth for the authentication frame, and then I put 0 to represent an infinite amount of the authentication frames to be sent, and then -C for client tells you the MAC address of the client, wireless client, in this case my Nokia. MAC address is going to be there, and then -A, and then I want to put the access point MAC address or wireless router MAC address, the router or the access point that the victim is connected to, its MAC address goes there, and then at the end of this command I put WLAN 0 monitor, the name of the network card. What is important is that I was watching Pink Panther from a top right hand side at the time 11:18 minutes. As you can see, the wireless connection on my Nokia phone is there, and the iPhone is hotspot and it's working perfectly. Exactly on the top left hand side, timestamp from the first column on the left hand side, you can see 11:18. At the same time, I issue the AirPlay command. What happens? It generates the authentication frames. What I expect is to target the association between the client and the access point, the wireless association between client and access point, between Nokia and iPhone, and bring it down. Uh, a few seconds later, from the bottom left hand side figure, you can see that my Nokia phone has lost its wireless connectivity to uh, uh, iPhone hotspot provider, my iPhone, and the online video streaming is paused there, um, and the wireless connection has gone, has lost, the association has been brought down because of the DoS or denial of service. I also confirm that at the same point of time, 11:18, from bottom right hand side figure on my mobile phone, as you can see, the association with Nokia phone has lost and has gone. Hope you have enjoyed it. Thank you very much. All the best.